start off quickly with a welcome video. Okay, amazing. So the purpose of Demo Day is for you to get a chance to see what our startups have been doing in the lab. We've had all these startups in for cohorts, and it's a chance for you to kind of see what they've been doing and what their outcomes are, and also what they plan to do in the future. So I encourage you to ask questions to our startups, Tesla, Carbon Chain, and Jupiter. And if you want to connect to them or get details and get more details about them, there should be information about them on their presentation. You can also use the network function on Hopin to connect with them, or simply email lloydslab@lloyds.com, and we're happy to kind of connect you ourselves. Also, something to note is that we have pitch day on the 27th of July, and the themes for the next cohort will be crypto, wildcard products, data and models, and claims. But let's focus on this particular cohort. And without further ado, we have Carbon Chain starting. Without further ado, we have Carbon Chain starting, and I'm just going to play that video now.
Hi, my name is Rohit Shah, and I'm the co-founder and COO of Carbon Chain. We are a London-based startup focused on organizing the world's carbon emissions information and making it accessible and useful to businesses across the world. Recent carbon legislation is forcing companies to understand and report on their carbon emissions exposure, and stakeholders are increasingly demanding more transparency into carbon emissions. For the insurance industry in the UK, the Bank of England has recently initiated climate stress tests for insurance companies in 2021, and the UK government has announced that all insurance companies must meet the Task Force for Climate-Related Financial Disclosures reporting requirements by 2025. However, when we speak to businesses that are trying to report on their carbon emissions, it's key that there are three key challenges that they face. First, it's impossible to get access to good data on carbon emissions. Second is that the mainstream solutions that are out there are consulting engagements that are quite expensive. And third, oftentimes the data that is able to be reported or the information that's able to be shared is backward-looking only, which doesn't help for future decision-making purposes. My co-founder Adam and I firmly believe in the saying that if you can't measure it, you can't manage it. So we launched Carbon Chain 3 years ago after realizing that the global carbon emissions data existed in a heterogeneous state that didn't enable easy decision making. We won $500,000 grant from the UK government to start building what is now one of the world's largest databases of carbon emission intensity information, and now work with a number of banks and large industry players. Our customers use our data in different ways, but fundamentally, it all boils down to understanding what the carbon emissions for their activities and investments are. To help our customers understand this, we take primary information from them, i.e. the companies in their investment portfolios, and overlay information from our database to produce a wide range of reports that help our clients understand what their emissions are. During Lloyd's Lab, the main question that we wanted to explore was how our carbon data could be used by insurance companies, and we were lucky enough to test 2 use cases with our mentors that I'll take you through now. The first use case was on vessel screening, so looking at an individual ship and understanding what its emissions were, and we were lucky to work with our mentor Atrium and produce a very comprehensive emissions report for a sample set of ships. To dive into a bit more detail there, I will show this a anonymized version of this kind of report, where basically the input that we can receive from an insurance company is an IMO number that enables us to match in our database the ship that's being insured and pull out some information about it, like its ship type, size, and depth. It enables us to also then build a peer group that we can compare that ship to. In this case, the peer group is based on the ship type and the size, plus or minus 10%. And then once we have that peer group, we're able to rank the individual ship to that peer group. So this particular vessel that I'm highlighting here is actually quite bad, as it has a rating of, in essence, 100%. So it's a pretty poor performing ship, and we can give it a rating of E on an A to E scale. This enables us to help our customers quickly understand when looking at a portfolio of ships that they are insuring or underwriting what's good and what's bad and what's ugly. The second use case that we looked at was portfolio screening. So in this case, we were looking at a much higher level at individual companies that were in a portfolio. We took a random list of companies and worked with Tokyo Marine Kiln on understanding what this could look like, and again produced a carbon emissions reporting tool for them. In this case, we were able to take a given company and then basically rate those companies in terms of their emissions intensity, high, medium, or low. What we were able to do was, from our database, pull out the emissions for that company, and then from publicly available data, understand what their revenue was, to then come up with an emissions intensity metric of tons of CO2 per $1 million of revenue. That enables us to rate the companies in the portfolio, but then also rate those companies within its own sector, so such as materials or even within the specific industry, so you can compare at a high level, but also get a bit more granular as well. In terms of the lessons that we've learned from the Lloyd's Lab experience, a few key ones to mention. First is that the general consensus from everyone that we've spoken to from our mentor group is that it currently seems too soon to incorporate carbon information into pricing decisions, but there is definitely a need that everyone sees for this information to start being surfaced, as it would potentially be something to look at for the future. The second is that even though it's maybe too soon for pricing, there is a need to start reporting on this information both internally and externally, pretty much ASAP. And then finally is that senior leadership is really needed to come on board to drive application of tools like Carbon Chain throughout the company to basically help people use this information in a productive manner. In terms of our next steps, we are actively exploring commercial opportunities with a couple of the mentors that we've been working with. We're also open to working with new companies to see if our data can be helpful to you. So thank you for your time. I'm happy to take any questions now, or feel free to drop me an email at rohit@carbonchain.com if you'd like to organize a meeting to discuss how we could support you in your carbon journey. Thank you very much.
Okay, perfect. And we currently have Rohit here with us today. Hi, Rohit. Thanks so much for joining us.
Hi, everyone.
Okay, so we have a question from Marissa. And she just asked, are you able to provide ratings for non-public listed companies?
Yes, we can. We have to use a bit more creative data science methods to do that, but we're able to give an indication for non-public listed companies as well.
Cool, thanks so much. And we have some questions from email as well. So how quick and easy is this to do? Is your
It's
solution to
pretty
do?
straightforward. We can turn around results within 1 day once we have initial inputs.
Cool. And where do you get your data from?
We get our data from a mix of public and private sources, so from public databases like the EPA in the US or from the European Union, as well as private data sources that we're able to purchase.
Great. And guys, do feel free to kind of ask questions, put your questions in the chat. Cool. We've got one here. Can you elaborate on the database that you own and how this is built and validated?
Yeah, so as I was saying to the last question, we source and scrape data from public and private sources that we're able to put into our central database. We then validate that using independent actors, people like SGS, who are able to basically ensure that the data that we're providing is accurate.
Perfect. Thank you. And Katie has asked, do you think insurance companies are behind the curve on utilizing carbon-related data compared to other industries?
That's an interesting question. I think the insurance industry is a bit behind when it comes to some of the other industries that maybe have been given a brighter spotlight. So people like oil and gas and metals, who have been, getting a lot of the brunt of the attention when it comes to carbon emissions lately. That being said, I think there are now a few companies that are taking a first step, which is great, and Carbon Chain's here to support all the others that want to take that first step as well.
Yeah, amazing. And Marissa has asked, do you need a company's permission to share their carbon rating?
No, so the ratings that we do are done by Carbon Chain, so that's proprietary to ourselves, so we can disclose that to whomever we wish.
Cool. And Conrad has asked, can the captured data be automated?
Most definitely, that's very much the aim that we are trying to do as a tech company, that we are building out automation for all parts of our data gathering, storage, and analysis components.
Cool. And Paul has asked, what are the implications for the insurance sector in not measuring this type of data in the future? And when will it become mandatory? Will this create implications for underwriting certain companies, vessels, assets in the future?
So I think the way the world is generally moving, not just within insurance, is that the world is starting to realize that they have to measure what's going on in terms of carbon emissions if they want to start making an improvement on it. So I think for companies that don't lean into this, you're going to find yourselves left behind and potentially very much on the back foot. In terms of when it will become mandatory, there are lots of different regulations in different countries. I think I mentioned in the presentation that the UK has required all insurance companies to report to the TCFD requirements by 2025 as one. But ultimately, when you see the fact that so many companies are increasingly starting to say they want to become net zero by 2030, 2050, 2060, etc., that's really going to drive forcing all industries to have to start reporting by those dates. In terms of implications for underwriting certain companies, vessels, and assets in the future, I can share an example from banking where we do a lot of work, and banks are starting to look at assets or vessels or companies that are higher carbon with a greater level of risk, and so are basically trying to, assess whether or not they should be giving the same kind of rates or same kind of risk profiles to those assets. And we're starting to see that ones that are high carbon are definitely getting higher risk levels.
Right. Yeah. And Craig has asked, have you a use case for asset portfolios in companies within allied to insurance asset management, for example?
Yes, we've looked at that. We've worked with asset management in the past, and so we can definitely look at those kind of asset portfolios in the companies and basically help understand what those emissions look like.
We also have a question about what are your sources for a company's data?
Again, it's a mix of public and private data sources that we go for. So, that's something that's very much core to our IP. So we're happy to disclose that under NDA.
Fair enough. And Matt Carter has asked, to add to Katie's question, did you concur that it was too early to drive pricing for your work, as pricing is likely to be a key driver to change behaviors and therefore better carbon emissions, and surely just a small rating adjustment is in the right direction?
Yeah, I do think that maybe we were a bit early in terms of trying to help drive that pricing discussion, but I think ultimately that's where the industry is going to have to go. Measuring is the first step, and then from there you can understand how to actually apply that to change, first of all, pricing, but ultimately behaviors and actions.
And Trevor has asked, do all newer ships have a better carbon footprint than older ones?
No, it's not that simple. We wish it was. A lot of the emissions that come from ships actually can be driven by the performance. So if a ship, an older ship, is being operated at a high level, and let's say going at a slower speed, its emissions could be less than a newer ship that's going at a much faster speed and not being operated as efficiently.
And Ed has asked, are others doing this? If so, how are you guys different?
So as a supply chain focused company, we look at all aspects of companies and every stage of the value chain. There are other companies that are looking at carbon emissions for sure, but they don't look at the full end-to-end view. So ultimately, we're able to help people understand all the way from an asset level up to a company level and everything in between.
Perfect. And Craig has asked, have there been cases where certain companies have employed carbon offsets, and is that factored into the data mix, e.g. cap and trade, emissions trading?
Yes, we can look at that, and that's something we've done before.
Cool. And another question from email, can your data be accredited or verified?
Yes, it most definitely can. I think, as I mentioned a couple minutes ago, we do work with independent companies who are able to accredit and verify the data that we have and the results that we put out.
Cool. It looks like that might be the end of our questions. I mean, if anyone has any other questions, please put them in the chat. But we've got a couple minutes left. I don't know if there's anything else, Rohit, that you want to kind of talk about Carbon Chain, like what your future plans look like. Oh, actually, I think we do have another question coming through.
Okay.
You mentioned the government funding. What were the government looking for from this?
Yeah, so we were very much lucky to be supported by the UK government initially and to this day. As you might have seen in the press, a big part of what the government's looking to do is to build back green. And in November of this year, the UK is hosting COP26, which is the world's premier carbon and climate change conference. And so I think the UK government is really looking for a chance to shine and really show how the UK is being a leader in this sector. And so Carbon Chain is happy to play a part in that. And hopefully through some of the conversations we've had in the lab and potentially with new conversations after, we're able to help some insurance companies also be able to present at that forum and really show the world really how you can actually use carbon data to look at your business.
And Marissa's asked, is there a limit to the size of companies you can provide a rating for, i.e. any prior conditions?
No, there's no limit. We can really look at anything from small startups like Carbon Chain to massive large companies like Amazon.
And I guess I have a question as well. I.e. lower limit, she said. So I guess as a continuation of her question, any prior conditions such as lower limit?
No.
So no.
Yeah.
And I guess I can add in a question. You sort of mentioned before that you look at the whole supply chain, like the end to end. And I was wondering, is there any other factors you take into consideration, like perhaps like human rights, or is it purely is your sort of ratings purely focused on the carbon footprint of a company?
No, it's a great question. So we very much focus on carbon emissions and the carbon footprint of companies. That's not to discount things like human rights or water usage or any of the other components, let's say, of a wider ESG perspective. But what we found since we've been doing this for the past 3 years is that carbon emissions are very quantifiable, and it becomes very numbers driven, and it's not as fuzzy as, let's say, some of the other topics that are out there. So we really find that there's value to be given by really quantifying companies' emissions and helping them understand what they are and how they can reduce them.
Cool. Yeah. And yeah, Rohit, I'm not sure if there's anything else you want to kind of like put out there in terms of just carbon chain and what you guys are doing and what the future looks like in your.
I think the main message I'd say to everyone is that, you know, the first step to understanding what your emissions are is really starting to measure. And so whether that's at, you know, a very high level view or a very granular view, we're there to help and would be happy to engage with anyone who's interested in learning more about their emissions.
Perfect. And I think we have time for just like one last question. Do you need to disclose to the company that you're using their carbon emission, even if it's public?
No, if our data sources are public information, then we're able to use them freely.
Perfect. Well, thank you so much, Rohit. I think that's kind of comes to the end of our kind of session. It's been really interesting kind of learning about carbon chain and what you guys are up to.
Sure. Thank you very much. All right. Have a great day.
And I mean, obviously we have your contact details, but if anyone wants to reach out to you, Rohit, I think you're just sticking around, so you'll be on Hopin, but you can also find you through what's your email, just in case.
My email is rohit at carbonchain.com. I'll put it in the comments for everyone as well. So please feel free to reach out if you have any future questions.
Perfect. Thank you so much.
All right. Thank you very much.
Awesome. Thanks so much, everyone, for all your questions. Definitely keep them coming. We're going to now move on to Testo, who is on next speakers. So I'm going to play the video now.
Hello, this is Marine Ujuroyo. I'm Teselo co-founder and Chief Strategy Officer. And today I'm going to discuss about geospatial intelligence for forest insurance. So let me start with a quick presentation of Teselo. We are a Portuguese environmental firm based in Lisbon, and our mission is to help organizations manage natural resources in a more sustainable way by using geospatial intelligence. Our R&D has been funded by the European Space Agency and the European Commission in the first years, and we are now selling our services on two markets, the forestry and infrastructure sectors. So we have a pretty straightforward technology. You can see a few images of the process on the screen. So we start with raw open data. We automatically clean them, removing clouds and making all the atmospherical corrections. We stitch all the pixels together to create composite imagery at country scale. And we then run our AI models to extract the relevant information for our clients. We deliver all our solutions through our cloud-based proprietary platform that you can see on the right. So all of our services allow our customers to protect their assets, trees, vegetation, soils, etc., by detecting pest attack and other kind of threats, to optimize their operations, for example, logging operation or vegetation management around power line, and at least to comply with environmental regulation. For example, we can measure the distance between trees and critical infrastructure such as power line. So you have here a few examples of our current clients in Portugal, but also in the rest of Europe and in Asia, Africa, etc. The starting point, we have observed that there is a huge market gap when it comes to forest insurance. Basically, forests are a very valuable asset that is largely uninsured all over the world. Let's have a look at some numbers here. $536 billion, that's the value of the forestry and logging market globally. Forests are also more and more used for their carbon sequestration performance, and carbon is expected to be, its value is supposed to be multiplied by 2 to 4 by 2030. And in parallel, in Europe itself, only 2.5 to 25% of forests are insured. So we have decided to apply and see how our tech could allow to untap this forest insurance market potential, and also to explore other potential applications such as other natural disasters or parametric insurance in general. Let's reflect now on these 8 weeks. So we have run a lot of key informant interviews. We started with the demand. So we have been talking to our own clients and other organizations to understand if they had an insurance to protect their plantations, and if no, why. We then turn to the supply, of course. So through our mentors, we've been able to reach out to a lot of very representative insurance companies. You can see the name on the screen. And last but not least, we have also been honored to be invited by the Instech podcast to be featured in one of them edition and talk about geospatial intelligence for insurance. What are the main findings of these interviews? So first, we've been able to really pinpoint the critical aspects to bear in mind when it comes to packaging our data. Of course, it starts with the perils. So regarding forest, the most common perils are wildfire, storms, and in a lesser extent, pest attack and drought. All of these are natural phenomena that we are already detecting for our current clients, which means that we are adapted to the purpose of the insurance product. Now let's have a look at temporality and repetition aspects. So we are able to go back in time, retrieving decades of satellite imagery, which is very useful at the start of a process of insurance to screen the risk based on past disaster. But on the other hand, on our own, we are not able to predict future risk. We would need to be completed by other set of data and risk modeling skill that we don't have today. For precision now, we usually work at 10 by 10 meter resolution. It's more than enough for forest. That was the first good news, but it's very often insufficient for crop pest attack, for example, that typically require a sub-meter resolution. And regarding distribution, we have concluded that it would make more sense for us to use intermediaries such as risk agency instead of directly selling our data to insurance companies. So the key messages, it brings me to the first of them. We have measured the complexity of insurance product, and we now know that we are only a fraction of the data necessary to screen a risk or to assess a price. So we would need to be completed with other set of data, weather data, for example, but also property data, to translate what we are seeing into a financial information. Now, the good news is that there is one exception, and it's, of course, the parametric insurance, because it's based on only one single index. Forests remain our number one target. We have observed that it's a smaller market than expected because the trees' life cycle are very long, 10 to hundreds of years. The risks are also naturally very high, which is driving the premium so high that a lot of timber producers prefer to not to insure the forest and to face the risk of any type of peril. The most common figure we have heard is that the total value of premium would only reach $500 million globally. Agriculture, it's not a great fit for now for Teselo because the life cycle are very short for crops, and because so it requires a very much higher precision and resolution that we don't currently offer. And to get there, we would need a huge effort of R&D that doesn't necessarily fit our strategy right now. Where does it take us? Well, first, it's been a very insightful journey because we've been able to really pinpoint the added value we could have at each step of the insurance value chain. we have decided to focus on the low-hanging fruits, which is very concretely stick to the phenomenon that we are already observing for our industrial clients today. And we have identified very concrete next steps. So that's excellent news. We have started a conversation to collaborate with a parametric insurance company, and we are building a use case focusing on fire risk in industrial plantations. So on the right, you can see an image of Portugal where we have mapped the fire that ravaged the country in 2017. We were able to assign a severity score to each pixel of 10 by 10 meter resolution. And that this is a starting point of the collaboration I've just referred to. In parallel, we are also going to continue the identification of other potential partners that would be data distributors and would very efficiently allow us to reach out to insurance company by repackaging our data into data set that would offer a more complete solution for insurance companies. So I would like to thank again our mentors, the Lloyd's Lab and the Elmark teams for allowing us to reach this conclusion and to have started this very promising conversation. Thanks a lot, and reach out to us if you want more information.
Okay, awesome. And I now have Remy here with me
Hello.
to ask questions. Hi, Remy.
How are you?
I'm good, thank you. So our first question that we have is from Trevor, and he's asked, do the clients you spoke to recognize the value risk transfer through insurance?
Yes, they do. The client we spoke to, or prospect client in this case, would be a forest manager who needs to insure the stock of forest. Yes, they are interested in insurance products. The problem is that the premium is usually too expensive. So its economic relationship works for industrial plantations, but very barely. And for small forest owners, that stop working right away. So that's why forests are not insured. The risk is too high, and the premium is too high.
Yeah. Sorry, I think you might have answered this. You just answered this question, not Trevor's
Yes,
question.
exactly. The premium is too high.
Yeah.
So
exactly.
the main problem of forest, our main finding, let's say, on insurance for forest versus agriculture, that agriculture, the cycle are very short. We are talking about 3-4 months of a season, and so here we can insure seasonal risk. Will there be a drought or not? And the insurance is quite straightforward. When it comes to trees, we're talking about insuring over a period of 10 to 30 years when it comes to industrial timber. And so, of course, it's very difficult to map a risk over 10 years, especially with climate change. And the risk is indeed very high. The probabilities as a fire strikes in Portugal in the next 10 to 30 years is high, for example.
And Craig has asked, speaking of low-hanging fruit, have you explored crop destruction following weather events, e.g. banana crop following hurricane in crop farm recovery forecasting?
Yes, we've explored last year, not this year with Lloyd's, but last year as a case study for we worked on hail and fruit trees in Southern Europe. So how hail is destroying fruit trees, especially apples, and but again, the problem here was that we could map the destruction of the fruit, but a bit too late in the process, so it's we cannot do a parametric insurance with it because we are not reactive enough. There's no way to be reactive because hail is very difficult to predict, and for traditional insurance, it doesn't really make much sense. So yes, we've tried. It's technically possible. The main finding is that our technology is really adapted to insurance. It's just the market is not here. The risk when it comes to trees, even fruit trees, is very high.
That makes sense. And Trevor, going on from the high, is the premium really too high, or are they underestimating the risks?
The premium is really too high. That's really clear from our conversation. The risk is here. When it comes to forest, I work a lot with forest managers. They're all obsessed by fire or by pest. They don't understand the risk, but they believe it's cheaper to take prevention measure to take care better of the forest than to buy a premium.
That makes sense. And got a question. Oh, we've got a question from Rachel, and she says, "How do you see an affordable insurance solution for forestry given the level of risk? Is that a case of you using your technology to target the risk better?"
All right. So there is one specific low-hanging fruit where insurance works. And that would be when the ratio risk and value of the premium is okay, and that's in industrial plantation. So we do have some customers that are interested, that are buying forest fire insurance. It will be a parametric. So we are in discussion now with a parametric insurance provider to do a forest fire insurance. And our target would be huge plantations in South America, in Asia. That's where the ratio cost risk premium is affordable for the industrial for the company.
Cool. And well, it's more of a comment, but Craig just said, "Got it." So insurers snapshot crop at inception, and then during/after events.
Exactly. So our fire spider, as soon as they have fire, every week we send a map with the number of pixel burns, basically, or where, or every week or every month, depending. But the idea is we continuously monitor, and it's every time we see a pixel that has been burnt and identified as forest, of course, we signal it, and we can send the fire severity index as well.
Makes sense. And yeah, and we've got some questions through email. So can you increase the 10x10 resolution of the satellite imagery?
Yes, so we do that more and more. So now we've developed a super resolution modeling, and so we can bring our output is around 1 meter. What is 1 meter? So even if we use native resolution of Landsat, which is 30 meter, or the native resolution of Sentinel-2, which is a European satellite, which is 10 meter resolution, we can obtain maps that are 1 meter resolution and that are extremely accurate.
Cool. And also, can you monitor any type of tree or plant?
Yes, we can. So with machine learning, we can differentiate tree species. We can look at health in a very reactive time. There's a lot of things we can do with machine learning and artificial with machine learning and satellite imagery. And at Teselo, we've been focusing on trees essentially, and it's extremely it's impressive everything we can say about trees with just a green pixel. With machine learning, we manage with tree to so species, health, volume, growth rate, height, age of the trees. There's a lot of things we can say with machine learning. Now, how to apply that in the context of insurance? That's another story.
Yeah. What is it? Is it harder to analyze certain trees compared to others, or?
Definitely, it's so we have two main activities. One is monitoring plantations of trees, and the other one is to measuring carbon stock of carbon in plantation or in natural forest. Natural forest is far more difficult to analyze because far more diverse. We have also some crops that are a bit difficult but not impossible to analyze, like coffee. Coffee grows under the shade of other trees. And so if you want to analyze a coffee plant, you have to analyze the canopy of the trees above, and as they connect together, we can find some relationship with them. So they're a bit more difficult, but it's very interesting. And some areas are more difficult than others. It's easier to look at in temperate environments than in equatorial environment, for example, where you have a lot of clouds. But even though now we've developed algorithms that remove most of the cloud, and now we can work pretty much everywhere.
Interesting. And also, are you able to estimate forest carbon sequestration?
Yes, yes, so we do that. We compute biomass we compute land use and biomass over time, usually over a period of 10 to 20 years. And we see the evolution, and we can see how the land use and the net density of forest has absorbed carbon, and so we can measure if a country or region is within its target, for example, of how much carbon has been sequestrated.
And Ed has asked, who is the buyer of the insurance?
So the buyer of insurance for the insurance we've identified as a low-hanging fruit, the buyer insurance would be the pulp and paper producer or the furniture manufacturer. So think, pulp and paper companies, IKEA, things like that. They are the one who owns large industrial forest and of fast-growing trees. So eucalyptus 10 years and pine 30 years, which is fast. And so for this very large plantation, insurance makes sense.
Okay, cool. I think that's all the questions. I mean, if anyone has any other questions, please put them in the chat. I don't know, Remy, if there's anything else you want to kind of get across when it comes to Tesla and your journey in the lab and
So well, first of all, I'm sorry to be here. I'm not Marine. Marine is the one who worked a lot on who worked day to day on this Lloyd programs, but she's today on holiday. So you have to deal with me. But yeah, it's been extremely insightful. We learned a bit the hard way that insurance market is extremely complex. First, with a lot of intermediary, etc. That designing new product in insurance is extremely complex. But it opened up for us a lot of possibilities in designing future product. We could better understand how the market is going into what phase. Parametric insurance is something that will be more and more important, even though I would have expected before doing this research with Lloyd that it will grow faster, parametric insurance, but that's something still has a lot of potential. And so I think there will be in the future more and more market related to satellite imagery and insurance. But for it to be more complete, the satellite imagery will have to be more granular to gain repetition and frequency of usage and gain accuracy as well as reduced acquisition cost. But I'm sure that all of that will converge in the next years, and I believe most of agriculture or forest insurance in the future will be some sort of parametric insurance.
Awesome. Well, thank you so much, Remy. Thanks for your time, and we look forward to kind of seeing what Buffalo does in the future.
Thank you very much.
Cool. So now we're going to move on to Jupiter. I'm going to play that video now, and then we're going to have a discussion with Mark. So I'm going to add to the stream.
My name is Mark Lehman, and I head up business development and partnerships for Jupiter Intelligence in the UK and Europe, a leading provider of physical climate risk analytics. I'm joined today by my colleague Megan Purdy, Senior Product Manager, who will provide you shortly with a demo of our Climate Score Global tool. Firstly, though, I wanted to pick up on the original pitch by my colleague Matt Stein and give you a quick overview of the exciting journey we've been on with our 4 mentors at the Lloyd's Lab over the last 10 weeks. Generally speaking, I think we all recognize that climate change will continue to have a severe impact on many organizations and businesses around the globe, including the insurance sector. But failing to prepare now is essentially preparing to fail in the longer term. The importance of having robust climate data to support a resilient market was further reinforced only last week in statements at Lloyd's by both Prince Charles and Carnegie Brown. We embarked on this journey by mapping out what we're hearing in the market from our mentors relating to specific challenges around climate risk and seeing how Jupiter can help to address these using our market-leading data and sophisticated analytics tools. What we heard specifically were challenges in relation to how confident the market is around current day climate risk and the future rates of change. How will this affect my portfolio exposures and cap pricing now and into the future? And should I be thinking about adjusting the underwriting strategy to account for climate risk? What if I'm the last insurer to adopt a robust climate-adjusted view of risk? How can climate data be used to improve our longer-term profitability and address regulatory requirements? Reflecting on this, we co-developed a number of use cases that address the needs of our mentors from both a business critical standpoint, but also those that were likely to see some clear climate signals over time. These use cases included, as we can see here, the first three, which were used for the lab demo and what we're going to show you shortly. So North American hurricane risk and sea level rise for industrial exposures, looking closer to home at UK flood risk for residential, and finally Canadian flood risks for a commercial portfolio. But then looking longer term in terms of potential commercial pilots, we considered less traditional situations such as drought and extreme temperature risks for agriculture, US severe convective storm for renewable energies, and wildfire risks in terms of US, European, and Australian residential and commercial exposures. With that, I'm now going to hand over to Megan to present a demo of our tool in action for the first three use cases we see here and based on sample property portfolio data shared during the program. Over to you, Megan.
Hi all, thanks for joining today. When I talk to insurers, I often hear the same refrain. We can change our prices every year, so why should we care about forward-looking climate metrics? Of course, because the regulator told you to is a powerful motivator, but I hope to show you today how climate data can lead to better outcomes in your underwriting and portfolio management practices. Our Lloyd's Lab mentors very graciously provided us with several data sets around the world. We then ran them through our Climate Score Global tool, which models physical climate risk anywhere on the land surface of the planet, from heat waves in Namibia to tropical cyclones in Hong Kong. For this demo, we're using Tableau to slice and dice the output. On our home dashboard, we can view the share of our portfolio's TIV that is exposed to various climate hazards: extreme heat and precipitation, flooding, high winds, hail, and wildfire. Locations are put into the highest bands for risks, such as being exposed to 30 days per year of 35 C temperatures, or for wind, being exposed to major hurricane force winds in a 100-year event. Right here, I'm looking at present-day exposure to these hazards, but I can toggle this view over here to look at different years in the future. And I can also look at this under different climate scenarios, from a Paris-aligned RCP 2.6 scenario, which keeps warming to 2 degrees by the end of century, or an RCP 8.5 scenario here, which is much more severe and is a more business as usual case. Now, this data is all very interesting, but it's really hard to figure out what the story is that's going on with this portfolio. And so for that, we turn to scores. So here I am showing just cities in the UK, and I'm showing all peril scores. So this is a blend of all of our different perils that we model. On the x-axis here is the present day hazard score. So this is the data that you're working with today, right? Using your CAT modeling info and using your claims history, you can sort of understand where these different cities lie. On the y-axis though, that's what you gain with Jupyter data. You can see where this data is changing in the future. So you can see some places might start out high and stay high. Other locations might start out low, but then get high just for them. If I isolate flood here, like this, I can start to see a couple of cities that show up on this y-axis right here. So a city like Salcombe, which is on the south coast in Devon, has zero risk in our present day model, but that's changing very quickly in the future. So just looking more carefully at this particular location, I can see here in this bar chart, the 200-year flood depth that a location is exposed to. No water in 2020 and 2025, but growing up to 0.3 of a meter by 2050. In red, I can see the resulting loss from an event like that. Of course, this only assumes a steady level of exposure, steady asset value. If I want to incorporate, let's say, a 2% inflation perspective on here, I can overlay that. And now this teal line is showing me that as the value of this particular home increases, I can see increasing exposure to these different flood depths and resulting loss. So a lot of these portfolios tend to sort of balance on a nice edge of profitability. You have combined ratios around 98% for many of these. And so even a small increase like this can tip an asset from profitable over to unprofitable. Now, it's not all doom and gloom when we think about climate risk. Returning to our city level scores, let's look at Canada in this case. All right. So flipping over to just personal and repair services, so small commercial assets, I see here that this bottom chunk of the graph just really lights up, right? Something that wasn't even present in the UK is that in Canada, you see many cities that have very low falling flood risk over time. So I don't know where South Porcupine is, but I do know that Winnipeg is in Manitoba. And so I'm going to just look at locations there to try to figure out what's going on. So flipping over to this view, I've got over here different locations and different occupancies, primarily this small commercial. And I'm looking here at the 200-year flood depth. And I can see in general that from 2020 to 2050, these values are decreasing, in some cases by quite a bit, 40 to 60%. So why is this happening? Well, flood risk in Manitoba is driven by snowmelt in the Canadian Rockies. As the climate changes, we have less snowfall in the Rockies, less snowpack. That leads to decreasing flooding when those events happen. So I can actually see this by flipping over to our drought metric, which shows me that this drought increase is up almost 50% just in the next 30 years. Now, this is under a 4-degree warming scenario. If I flip this over to just 2 degrees, I can see that that drought risk is much more moderate. And as a result, I have fairly steady flood depths over time. So what we see here is that climate change effects can be quite myriad. Outside of relentlessly rising seas, there are unexpected stories like this one. As you work towards rebalancing your portfolio, climate data can help you identify not only regions that you should abandon or pursue rate increases in, but also the regions you should target for expansion. So finally, we'll turn to US hurricane risk and thinking about what the hurricanes of the future look like. Now, scientific viewpoints on tropical cyclone risk have long been varying, but that changed with a landmark paper published just 3 months ago. Jupiter models our tropical cyclones on a standalone basis to give us complete control over understanding the events of the future. And next week, we're releasing a major update that's going to incorporate this latest science. So in short, future hurricanes in the North Atlantic will be a bit windier, but much more wet. I can visualize this on this particular plot right here. So on the x-axis here is the 100-year extreme precipitation metric, the total rainfall we get in a single day. The y-axis is that same metric, but looking at it in 2050. I've got this one-to-one line here so I can understand where that risk is increasing. So if I'm above the line, these events, if I keep the frequency fixed, the severity is increasing. And so Florida is leading the way here with the highest rainfall events, but Texas in particular, which I can isolate right here, is seeing the highest increases in precipitation. So these events, like we got a preview of in Hurricane Harvey, becoming much more severe. Now, looking at wind speeds, I see that they follow this line much more closely. So the wind speed increases are less severe, but there certainly are outliers. So for example, if I hover over North Carolina, these locations actually tend to have the highest increases. Now, given that force increases with the square of the wind speed, even just a couple of kilometers per hour increase can have effects on a portfolio when it comes to assessing it for loss. So to isolate just the effect on loss, I've got one final chart to show you. This is showing me the technical premium that's going to incorporate uncertainty from different states over time and across 2 different scenarios. So down here, I see that Florida, for example, is expected to have a 2.6% increase in the annual technical premium just in the next 10 years. And the increases are higher in Texas and Louisiana for this particular portfolio. Moving out further, I see higher increases, and not surprisingly, by 2050, I see much higher increases. So 8% rise if we are on a 4-degree path in Florida just in the next 30 years. Again, looking at that more severe portfolio. So my question to you all is that I want to leave you with is, do you want to be the first to know about this so you can plan rate changes and adjust your underwriting strategy? Or do you want to wait for a CAT modeling release that's suddenly going to tell you 5-10 years down the line that they've been wrong the whole time and you're stuck holding the bag after all of your colleagues got out? So thank you very much, and I'll hand it back over to Mark.
Thanks, Megan. So just to conclude things, I thought we'd share with you a few key takeaways that we've learned during the course of this Lloyd's Lab program. So firstly, we've seen that it's pretty important to look beyond the traditional annual renewal cycle when considering the impact of climate risk on portfolio management, pricing, longer-term profitability, sustainability, and meeting the needs of the regulator. We've seen from the study, for example, that there can be gradual impact with the risk of additional shocks along the way that might erode away at the profitability. Then also the impacts are not necessarily uniform across a portfolio. We've seen variations depending on the type of peril, asset type, and geography, and identifying what we call as winners and losers within a portfolio to help drive strategic decisions for portfolio realignment. In terms of losses, we can see that small incremental increases in annual average loss will also accumulate over time and have an impact on the portfolio metrics, such as combined loss ratio or technical premium rates. And having foresight on this is really essential. And finally, climate change is increasingly becoming a board-level issue, and it's going to affect reputation and profitability. So building in the right metrics now will prepare you for increased scrutiny and disclosure later on. So finally, a little bit of feedback from the mentors themselves. At the close of the program, we'd like to thank them all for their time and dedication to work with us on this amazing Lloyd's Lab program and for sharing data and their considerable expertise. We were able to work through the most important use cases and bring climate risk into an underwriting and portfolio management context. Jupiter also extends its gratitude to the organizers at LMARCS and Lloyd's itself for making this possible and providing access to the wider Lloyd's network and relevant external parties too. We do hope that you found this demo to be of interest and look forward to speaking with you in the future, should you be interested to engage with Jupiter on a commercial pilot study. Thank you very much, and now over to Q&A.
Awesome. Okay, so we're joined by Megan and Mark. I think he's also there. Perfect. Great. So we've got a lot of questions, so we'll try and get through them. So Philip has asked, can exposure data from the well-known CAT models be imported into the program, and how detailed must the data be to generate meaningful output? For example, postcode, city, lat long.
Yep, I can take that one. So we take a CSV extract from any of the well-known CAT model databases with straightforward things like address and a handful of building attributes that you already have in your CAT model databases just for the loss calculation. Lat long is ideal, but we also have a geocoder inbuilt if you just have information like postcode or city. We also take a more index-based approach where if you have uncertainty in your geocoding, we can then do a scattering approach to sort of reflect the range of hazards in that particular area of uncertainty.
Awesome. And Richard has asked, obviously no two climate change models are the same in their parameterizations, model resolutions, etc. What metrics or methods do you employ to select or weight climate models that are used to create your outputs?
Sure. So we try to use as many models as possible because that gives us more simulations of future climate, which means that we can better resolve what the tail of the curve looks like. And so as long as it passes, basic information, like it has to be well vetted by the scientific community, we test it for bias against past simulations of past simulations of climate and so forth. But then we will take it in. Today we use an equal weighting because we don't want to put our finger on the scale. If you start thinking about using unequal weighting, that this one looks better than the other, then you start to get into that nefarious, you're just putting your own judgment on something. Like, it should look like this. We should see higher precipitation here. It's a really scary place to go. But today we're doing equal, but we expect to start thinking more about unequal in the future.
Perfect. And Alex Curtis has asked, how do you generate your climate metrics? How do you ensure your outputs are scientific and robust?
Yeah, so this could be obviously an hour-long conversation, but the short version is that we start out with global climate models from the CMIP 6 generation of models. That's the latest one that was released, and it's being used by the coming IPCC report that's going to be released next year. So we start with those, we assess them for bias. Then we, in some cases, will produce additional modeling on top of that. So like if we're doing hail, then we might take in additional metrics like wind shear and freezing level and other things to say, okay, what's the probability that we'll have hail there? And then there's a downscaling step also to take in local concerns. So like if I'm on top of a mountain, I'm going to have cooler temperatures. If I'm in a city, I'll be affected by the urban heat island effect. And so we can do a downscaling process then to understand how the broad view that we get from climate data is manifested at the local level.
And Rachel has asked, how do you benchmark how robust your analysis is?
Sure. So obviously we have no idea what's going to actually happen, 30 years, 50 years from now. But when we do have events, we use their observations, and we're always taking them in and improving from that. Really a much longer conversation, but there's a lot that goes on there.
Mm-hmm. And Trevor has asked, so if rates are right today, next year, they will be too low. Will they be too low? They will be too low.
Yeah, I think it's going to be a gradual process, right? Where we can see that we're moving further and further away from where we should be when it comes to rates, but we probably won't actually notice it unless there's a big event or unless there's a cat model vendor release, and suddenly you realize that, oh, I should have been 10 or 20% higher this whole time, right?
Yeah.
So using climate data, we can kind of see where that trend is going so that when there is a release, we'll be prepared for it.
Cool. And Andrew Brown has asked, is your geocoder proprietary? If not, who do you use?
We use Google. Yeah.
Okay. Well, thank you. I think that's all the time we have. For the questions. I don't know if there's anything else you kind of want to get across quickly when it comes to kind of Jupiter, your time in the lab, and your kind of relationship with the insurance industry.
Well, I've really enjoyed it and I really appreciate it. And one thing I wanted to say, I kept everything in the demo to just the next 30 years. But when you look at the next 50 years and even after 2100, you see a really big difference when you are on a 4-degree scenario versus a 2-degree scenario. Things like losses jumping up 25, 30% by the end of the century. And so even though we don't care about that time scale as we don't care about it as insurers, we do care about it for like next generations.
Right.
So what we see is that around 4 degrees, it's much worse. So everything that you're doing to race to net zero and all of those greening for the financial system programs that you have really make a big difference in the amount of peril that we're facing at the end of the century. So that's what really gets me excited about climate risk, even if we aren't going to be around to see when it gets really bad.
Okay.
I would just add that just very quickly that Megan and I sort of both come out of the insurance sector and have worked quite a lot of years in sort of this area. So for us, it's been an amazing experience working with the syndicates and mentors, and we're learning something new all the time. So this is just a kind of snapshot of the journey that we're on, and be very happy to talk with anyone who's willing to work with us.
Awesome. Well, thank you so much, Megan and Mark, for your time and for your presentation.
Thank you.
Thank you. Bye-bye.
Awesome. So thanks everyone for joining us for demo day over the past 2 days. Also just wanted to add quickly that if you're aware, did you know that that Lloyd's has an innovation class? It was launched last year, and it means that Lloyd syndicates can write an additional 2% of the class for innovation products. It's fairly flexible to use. If you want to get in contact with us or find out more, please just email lloyds@lloydslab.com. In terms of email addresses and getting in contact with any of the startups, they should be sticking around in their little booths on Hopin. If not, again, just email lloydslab@lloyds.com and we're happy to connect you directly. Should also be noted that pitch day will be on the 27th of July for Cohort 7, and the themes for that will be claims or wildcard products, crypto, and data and models. So if you want to attend, again, just send us an email. But yeah, that's all we have time for. Thank you so much for joining us this afternoon and over the past 2 days. I'm Femi, and I've been your host for this afternoon, and yeah, it's been great.